So let's predict the geometry of this hydronium ion. First, we'll need to draw a Lewis structure. We'll put the oxygen in the middle and put the hydrogens on the outside. And we know we've got 6 electrons from the oxygen, and we have 1 electron from each of the 3 hydrogens, and we have a positive charge, so we're going to take 1 electron away. We should have 8 electrons. So we have written 3 bonds, 2, 4, 6 electrons. We have a lone pair here. That's why we needed to do the Lewis structure, to determine whether there was a lone pair. Steric number, therefore, is going to be 4. We count each bond as 1, and then this lone pair counts as the 4th one. That gives us an electron group geometry that's tetrahedral. We have 1 lone pair, so that means that when we look at the molecular geometry, we don't count the lone pair. The lone pair is invisible because there's not an atom at the end of it, and so the molecular geometry, or the shape of this molecule, is going to be trigonal pyramidal. So let's look at this compound. Again, we're going to need to draw the Lewis structure for it. Boron has 3 electrons. Each of the hydrogens has 1 electron, so that's 4 altogether. And then we have a negative charge, so we have an additional electron. So there are 8 electrons. We have already drawn 4 bonds, so that accounts for our 8 electrons. We don't need to add any lone pairs. So we have a steric number of 4 because we have 4 bonded atoms. The electron group geometry is tetrahedral. The number of lone pairs is 0, and so the molecular geometry is also tetrahedral.